What is the main problem addressed by the proposed method in the paper?
The main problem addressed by the proposed method in the paper is the challenge of incorporating human revision edits to guide and enhance multimodal generative models in layout design. The paper focuses on how to leverage the valuable knowledge encapsulated in the iterative process undertaken by human designers to improve the generated layouts. Specifically, the paper aims to explore the impact of human revision edits on the performance of generative models in layout design tasks. The authors introduce a novel dataset, RARE+, which captures the iterative nature of human design revisions, and demonstrate the substantial benefits of incorporating these revision edits in training multimodal generative models. By studying the impact of human revision edits and comparing them against model-generated ones, the paper highlights the potential of closing the gap between human and model-generated designs in layout generation tasks.
How does the proposed method or algorithm work? Illustrate step by step.
The proposed method works by leveraging human revision edits to guide and enhance multimodal generative models in layout design. The process begins with the curation of a novel dataset called RARE+, which captures the iterative design process where expert designers revise and refine layouts generated from a specific language prompt. This dataset provides valuable insights into the evolution of a design. The researchers then explore various supervised fine-tuning setups for a Gemini backbone, a large multimodal model, to incorporate human revision edits. By training the model on human edits, the researchers demonstrate substantial benefits in improving the generated layouts compared to models that ignore human guidance. The researchers focus on the task of transitioning from an initial UI layout design and a language prompt to generating an improved final version that balances functionality and aesthetics. Different model setups are explored, such as the direct model, hop model, single revision model, and multi-revision model, each incorporating human revision edits in varying ways to predict the final layout state. Through experiments and evaluations, it is shown that incorporating human edits during training significantly improves the model's performance at test time. The single revision model, in particular, performs the best, showcasing the effectiveness of using human guidance in the iterative design generation process. Furthermore, the researchers analyze the model behavior in terms of iterative self-revisions and human-guided inference. They observe that models tend to duplicate input revisions during self-revisions, indicating an echo chamber phenomenon. By introducing human edits at early stages of the iterative process, the model's performance improves significantly. The study concludes that human intervention plays a critical role in guiding generative models towards producing more refined and aesthetically pleasing layouts, bridging the gap between model-generated designs and expert human designs.
What are the theoretical or practical benefits of using human revision edits to guide multimodal generative models in layout design?
The theoretical and practical benefits of using human revision edits to guide multimodal generative models in layout design are significant. The paper demonstrates that incorporating human revision edits in training multimodal generative models leads to substantial improvements in design quality. By leveraging the iterative and nuanced nature of human design revisions, the models can better capture the evolution of a design and balance aesthetics with functionality. This approach harnesses valuable knowledge encapsulated in human edits to enhance the generated layouts, ultimately bridging the gap between model-generated designs and expert human designs. The research highlights the critical role of human guidance in the iterative design generation process, showcasing how human edits can outperform model-generated ones in providing guidance for layout generation. Additionally, the study shows that human revision edits can help models avoid self-repeating behavior patterns and improve their self-improvement capabilities. In practical terms, incorporating human revision edits can lead to more realistic and aesthetically pleasing design outcomes, bringing the model-generated layouts closer to expert human performance. This approach can also help in refining design elements, organizing layouts, and aligning positions effectively, resulting in more coherent and visually appealing designs. Ultimately, the use of human revision edits as guidance for multimodal generative models in layout design can significantly enhance the quality and efficiency of the design process, making it a valuable tool for designers and developers in creating user interfaces and graphical elements.
How is the impact of human revision edits validated or tested in the paper?
The impact of human revision edits is validated or tested in the paper through a series of experiments and analyses. Firstly, the paper introduces a novel dataset called RARE+ that captures the iterative design process through human revision edits. This dataset is used to train and evaluate various model setups, including direct, hop, single revision, and multi-revision models. The models are fine-tuned on the RARE+ dataset and then tested to see how incorporating human revision edits affects the generated layouts. The performance of the models is evaluated using the Frechet Inception Distance (FID) score, which measures the similarity between generated layouts and human-designed ones. The paper compares the performance of models that incorporate human revision edits during training against models that do not use such edits. The results show that models trained with human revision edits significantly outperform those that do not incorporate human guidance. Specifically, the single revision model, which considers a single human revision edit, performs the best, while the multi-revision model, which incorporates multiple human edits, also shows improvement. The experiments demonstrate that human revision edits play a crucial role in enhancing the quality of generated layouts, as evidenced by the improved FID scores when human guidance is included in the training process. Additionally, the paper analyzes the behavior of the models during iterative, self-revisions, and human-in-the-loop scenarios to further understand the impact of human edits on the generative models.
What specific results were achieved with the best model variant incorporating human revision edits?
The best model variant that incorporated human revision edits achieved a remarkable design FID score of approximately 10, closely approaching human performance, which was around 6. This model variant substantially surpassed other models that ignored human revision edits, such as the baseline latent diffusion model, that achieved a FID score of around 30. Despite the inherent noise in human edits, the model variant that incorporated human revision edits demonstrated significant improvement in generating layouts, showcasing the valuable impact of human guidance in the iterative design generation task. The incorporation of human revision edits in the training of multimodal generative models for layout design proved to be highly beneficial, highlighting the potential of leveraging human expertise to enhance automated design generation processes.
What are the limitations or drawbacks of the multi-revision model in the paper?
The limitations or drawbacks of the multi-revision model in the paper include the fact that incorporating longer edit context from human revision edits can confuse the model during both training and inference. This complexity, introduced by sampling a subset of layout states from the edit sequence as a form of guidance, can lead to noise and potentially hinder the model's performance. Additionally, the multi-revision model may struggle to effectively utilize the additional revision context provided, as it needs to balance the amount of information from the revisions without overwhelming the model. This can result in the model not being able to effectively learn from the multiple human edits, leading to suboptimal performance compared to expectations. Furthermore, the multi-revision model may face challenges in aligning the human edits and the model-generated ones, which can impact the iterative improvement process of the model. Overall, the multi-revision model's drawbacks lie in its handling of longer and potentially noisy human revision contexts, as well as the difficulty in effectively leveraging multiple revision states to enhance the final design generation process.